So we're no longer using the words atoms. What happens is if one atom comes together with another atom and they form a bond, this is now called a molecule. Okay, so a molecule in simple terms is basically two atoms or two elements coming together. So an example of this would be hydrogen chloride, HCl. Hydrogen is one atom, chlorine is another atom. They're coming together and they're forming a bond. And now if they tell you to draw your Lewis structure for hydrogen chloride, the steps that you're going to do in doing this is first, you're going to draw your Lewis structure for hydrogen, which is going to look like this. Number two, you're going to draw it for chlorine, and chlorine looks like this. All right. If you go to your periodic table, you should see that your valency for hydrogen is a +1 and for chlorine is a -1. What does this mean? It means hydrogen needs to give away its electron, and it means chlorine wants to take an electron. So what happens in our third step is both of these atoms come together and they share their electrons. So this is a definition of covalent bond because there's a sharing of the electrons. We also learned that this is called a shared pair of electrons. Right? It basically means that those electrons are participating in the bond. So this is an example of how we do a Lewis structure for a molecule. Okay, and then the detailed steps are also here. So we can see from the picture, we have two definitions for the electrons around the atom. The first is the bonding electron pair because they are participating in the bond. Secondly, you have a lone pair. These are your electrons which do not participate in the bond. They could ask you to count or to tell them the number of lone pairs. So when you draw your Lewis structure, you must be able to count. For instance, here you've got 1, 2, 3 lone pairs, and you've got one bonding electron pair. We also went through the definition of something called a dative covalent bond. And this is a special type of covalent bond because it's basically a bond where your shared pair of electrons is only coming from one atom. So an example of that we've done here, where we could look at NH3 and the H plus ion. So remember the definition of an ion is basically when an element has a charge on it. So in other words, it's given away its electrons so that it has an overall charge. The H plus ion is a popular one. This has a positive charge because it's given away its electrons. So this actually has no electrons to it. So what happens in this case is you've got NH3, and we can see the Lewis structure for that looks something like this. Okay. And what happens is this hydrogen atom, which has no electrons, comes into the bond and it places itself here. So that nitrogen is the one providing the shared pair of electron. Therefore, this is the definition of a dative covalent bond. Right, we then spent some time talking about molecular shape. We're going to go through this one fairly quickly, just highlighting most of the important things here. Molecular shape. So the molecular shape is firstly very important because it gives us the atom's characteristics. It tells us about its boiling point, melting point, and also whether it's going to be polar or non-polar. We have something called the valence shell electron pair repulsion theory. It's abbreviated VSEPR. And basically this is a theory that tells us valence electrons want to arrange around the central atom. A detailed description is also written here, but in essence, it's basically telling you that if you've got your central atom here, then your valence electrons want to arrange itself around the central atom. Okay, and then that gives us a clue about how the molecular shape is going to look. So some of the common shapes that we get is listed in the picture here as well, but we first start off with something called a linear shape. This is the most basic shape, and we follow the general formula of AX or AX2. What this means is, for instance, if we look at HCl, the A represents one element, the X represents another. right? There's no subscripts here. So it's just 1, 1, therefore it's AX. So hydrogen chloride is actually going to be a linear molecule, right? You could see in the table, I'm not going to write down all of them, but you've got your angular, and it should follow this structure. You've got your trigonoplanar following this formula. Tetrahedral, one of the other common ones. So for instance, CH4, that follows AX4. Therefore, this is going to be a tetrahedral. Okay, and then we go all the way up to octahedral, although it's not very common. Now, what is important about these things is being able to understand what is a symmetrical shape versus unsymmetrical. So when we talk about a symmetrical shape, I mean, if we talk about something that's symmetrical, if you look at a square like this is definitely symmetrical because this side is the same as this side. So what it means in chemistry is that there is an even charge distribution. Okay, so all of the charge around that central atom is evenly distributed around it. If we take an example like the linear shape, okay, let's take HCl. If hydrogen has a charge to it and chlorine has a charge to it, this is going to be unsymmetrical because there's an uneven distribution of charge. You can imagine placing a mirror down here. If you slice through that bond, you're going to get two different charges on either side. Therefore, it is unsymmetrical. But if you look at something like tetrahedral, so a tetrahedral could be carbon attached to 4 hydrogen atoms, okay, like this. In this case, if you place a knife, if you cut down through the central atom, you notice that there's an even charge distribution. So this is an example of a symmetrical shape. Now, the importance of understanding whether it's symmetrical or not symmetrical is because if it's unsymmetrical, it means it's going to lead to something called a polar atom. Polar, again, it goes back to this not evenly distributed. If it's symmetrical, then it means it's going to be non-polar, right? It's not going to have an unsymmetrical charge distribution. Okay, so we went through a few examples here going through the shapes. You can do that as practice. The next important point we talked about was something called electronegativity. Right, so we talk about change in electronegativity. We're not going to discuss this in detail, but basically it tells us the element's measure or how strong that element is pulling on the electron pair. And we know we can do this by a calculation. You simply go to your periodic table. So for instance, if you're talking about HCl, you go to your periodic table, you find out what is your electronegativity of hydrogen and chloride, and you subtract those two electronegativities, and you should get an answer from there. Now, all of this theory is leading us to the point of talking about what type of bond we're dealing with. So the next important thing is we talk about the type of bonds we have. Now we know we could have a nonpolar bond. So that's your first type. You've got a nonpolar bond. Then you could have a weak covalent. You could have a strong covalent. And you can have something called an ionic bond. Now as you go down this list, an ionic bond is the strongest bond, right? So how do we figure out this? One way of doing this is to calculate your change in electronegativity. If you get a 0, you know that's going to be a nonpolar bond. If you want to have a weak covalent bond, that is between the range of 0 and 1. If you get a number between 1.1 and 2, that is usually a covalent bond. Anything greater than 2.1 is considered to be ionic. So if you ask the question, what type of bond you have, this is what you're going to do. Calculate the electronegativity, and then you use this table, which you need to memorize, to answer, is it nonpolar, is it covalent, or is it ionic? Okay, so furthermore beyond this, if a question asks you, is this atom polar or nonpolar, how do you go about answering that? So the first thing you do is you calculate your change in electronegativity. Okay, let's draw it in a flowchart. So the first thing you do is you calculate change in electronegativity. If you get your answer to be 0, then immediately you can say this is a non-polar atom, right? You don't need to do any other steps from here. But if you know that you're getting any number, okay, so we go back to the list. So if you're getting a number between 1.1, 0.1, so if you're getting a number between 0.1 and 2, then this means it's actually a covalent bond. Okay, if you're getting a number that's greater than 2.1, this means that it is an ionic bond. But you don't stop here, you actually have to do one more step further than this. You have to check what is the shape of this element you're dealing with. And if you find out your shape is symmetrical, then this means it's going to automatically make it a nonpolar bond. But if you find out that your shape is unsymmetrical, then this will hold. Okay, so it would be a polar bond. So this would be polar. Okay, so this is the steps you're going to take. You're firstly just going to calculate change in electronegativity. If you get 0, it automatically means it's nonpolar. But if you get a number, then it means you now need to check its shape. When you check its shape, if it's symmetrical, it's automatically a nonpolar. But if it's unsymmetrical, it means it's a polar bond. Okay, so here we did a few examples as well, figuring out our different shapes and whether the molecule is polar or non-polar. We've got a few examples here that you can work through. And now we're ready to move over to our next section, which is talking about intermolecular forces.